students, my name is Er.Gurminder Singh and today we will discuss about the engineering properties of the soil. So at very first, engineering properties of the soil comprise of physical properties, index properties, strength parameters like shear strength parameters, permeability characteristics, consolidation properties, modulus parameters and dynamic behavior, etc. So in the engineering properties, the some properties of the soil of internal particles are present, like index properties, which we have discussed yesterday, and in which the plasticity at Vogel limits and particle size distributions are there. And next is your very common or the very important factor is your shear strength parameters and permeability. So there are the various methods of determining the soil properties. Very first one is your in situ testing data, where we use it on the field, and the second is your laboratory testing. In the laboratory testing, first we have to take the sample from the field and where it is facilitated, and then after that it put into the laboratories for the various tests, and for the particular days or particular time period. So at very last is your back analysis based on the site performance data. So whenever we have an in situ test in the field to verify it, so we analyze it back into the laboratories, maybe for the other valuable things or valuable values based upon the internal test in the laboratories. So what are the various laboratory tests are there to for find the special parameters of the soil? The laboratory testing is take place, like to find the strength, stress, strain, compressibility and permeability characteristics, right? So it is a there is a very important factors called cohesion. What is cohesion? It is the internal molecular attraction which resists the rupture or shear of the material. What it that mean? That in various, whenever there is a various particles of the soil present, and there is a force that which attract each other with the help of the moisture content present there, is called the cohesion. With the help of the cohesion, the shear strength of the soil is maximum. So cohesion is deserved in the fine grained soils from the water films which bind together to individual particles in the soil mass, right? So cohesion is the property of the fine grained soil. It is only happened in the fine grained soil which has size is 0.002 mm, or it's also called 2 microns, right? So it is only possible in the fine grained soil like clay soil and silty soil. Otherwise it is not present in the gravel and sand, because they have a particle size more than 2 microns. So cohesion of a soil decreases as the moisture content increases, and cohesion is greater in well compacted clays, and it is independent of the external load applied. So whenever the soil or clay is highly compacted, then the cohesion is maximum in that soil. So next is your angle of friction, internal friction, that is very important in the soils for taking the loads from the structures. So to find the resistance in sliding of grains particles of a soil mass depends upon the angle of the internal friction, right? So whenever we talk about the hilly areas, the soils have a higher angle of internal friction. Because of that internal friction of angle, there is a more friction in between the soil particles, and they have not replaced from their original places, so our structures are safe on the hilly areas. So it is usually considered that the value of the angle of internal friction is almost independent of the normal pressure, but varies with the degree of packing, right? So it is varies from the degree of packing. For example, we have a different particles have a different shapes packed together or overlap together, but as a contact area is different between the two particles, so we can say that there is a different angle of friction, right? So the angle of frictions in clay is 0 or maybe such that 26 degree, and the angle of internal friction in a granular soils may be vary from 28 degree to 50 degree, right? So next is your capillarity. Capillarity, what is that? Whenever your water is flows opposite to the gravity, it is called capillary, or maybe whenever its ability of the soil to transmit the moisture in all the directions regardless of any gravitational force, right? So we haven't depended on the gravitational forces there. Whenever soil particles provided a path to the water, it may be flows from one place to another place by the action of capillarity, right? So the capillarity, the maximum theoretical height of the capillary depends upon the pressure which tends to force the water into the soil. So maybe it is depending upon the pressure that is exerted from the upper structures to the soil. So the soil particles provide the path to the water flows from the up lower side to upper side opposite to the gravitational force. So there is a uh, different type of heights of the capillary water in the different type of soils that is mentioned as you can see on the screen. And your next parameter is your permeability. That is permeability, that is an important factor in the soil. Permeability of the soil is the rate at which the water flows through it under action of hydraulic gradient, right? So what is hydraulic gradient is there? A hydraulic gradient, it means the whenever there is a two pressure heads, very first one is your upper side and second one is your lower side. So as per the differences in the pressure head, the water flows from the upper side to the lower side. So in it is also applicable in the soil masses. So the passage of the moisture through the interspace of the pores of the soil is called percolations. Percolation means that water can percolate in the soil within the voids that is present in your soil, right? So soil having porous enough to percolate and occurs are termed pervious and permeable. So if we have a soil that permit the water flow through inside, so the soil is called your pervious soil or permeable soil, right? So the rate of flow is directly proportional to the head of the water. So whenever your head of the water is at upper side, or maybe heights varies from the place to place, so your uh, water is flows as per the head of the water. So permeability is the property of the soil mass and do not of individual particles. So it is a property of the whole mass. Like we have a site of the 10 by 10 kilometer, so we can say that this is a property of the 100 kilometer area of the soil, not a single particles of the soil, right? So the next is your soil plasticity. What is soil plasticity? As a word you can know that plasticity behavior of the material. Soil plasticity is a property that enables the moist soil to change the shape when some forces are applied over it and to retain this shape even after the removal of this force from it. So whenever there is application of the load on the soil, there is a small change in volume in the soil. So whenever it is removed from the soil, it regain its shapes before without any deformation in there. So that behavior of soil is called soil plasticity. It is due to cohesion in the soil that is present due to the moisture content in the soil. So there is another force that is called adhesion. Adhesion refers to the attraction of the substance of unlike characteristics. To understand the cohesion and adhesion, that whenever the two particles of the water are interconnected with each other, have a same characteristic, like very first one molecule is of water, second is also of water, that is called, the attraction between them is called cohesion. So whenever the one particle of water and another particle of the soil, so it's called your adhesion, right? So the soil consistency depend upon the texture, amount of the inorganic and organic colloids structure, moisture content of the soil. So the consistency means how the soil is dense, and how much the solid particles are available in the soil depends upon the organic and inorganic colloid structure and the moisture content of the soil, right? The next one is your elasticity. So as the you know that from the word elasticity, that whenever we have a small change in volume in the soil, it regains its shape as in the small within time period. So it's that behavior of the soil is called your elasticity, right? So a soil is said to be elastic when it suffers a reduction in volume while the load is applied, but recovers its initial volume immediately and the load is removed. So there is a main difference in between them, that soil regains its shape immediately in the form of elastic, and but in the plastic behavior it's not regain its shape at instant, or it maybe take time from minutes to hours or maybe in days, right? So today we will finish the small number of engineering properties. In next class we will continue it, and thank you.